Hey, welcome back to Math with Patrick. It's June 14th, and we're solving problem number 165 from the Daily Epsilon calendar. And we need to show why this blue area marked with an X is equal to 14 today. We're given some information. We know like this side AC is split in half, it's bisected. We know that AB is cut into thirds, and then this inner triangle is marked 1/3 of the way from A to B. And similarly, this side is cut into fourths, and we also have a spot for where that blue triangle lines up with the outside triangle ABC. ABC also has an area of 48. So, well, I don't see any numbers here, but if we did like base times some kind of perpendicular height, divided that by 2, then we would get the area of 48. So on that note of like trying to find lengths, there aren't any here. These are just variables, and then if I wanted to split this in half, I could say like this is length P and that's length P because they're both equal. And it doesn't really tell me how long M, N, and now P are. Like they could be any length. I could squish down AC and make AB and BC a lot longer, as long as it's a triangle. My sketch doesn't really look that way. But also as long as the area is 48. And so we could really stretch or shrink the sides here, and apparently the area is still remaining the same. So to try to find the areas, actually, let's talk a little bit about the sine angle formula for triangles. It's going to be 1/2 times two different sides times the sine of some angle. And let me just kind of prove it to you by drawing a right triangle here. So let's just say that this is like side B and that's side A. And if I wanted to find the area of this triangle, I would do 1/2 times the base, which is A, and then times this height. But I don't really have the height yet. Like I would love to just put an H here, but what if I don't know that height yet? We could just use a little bit of trigonometry. We could do the sine of our angle here. I'm just going to call it H, capital H. And sine is defined to be opposite over hypotenuse, like that. And then if I wanted an expression for this H, I could just multiply the B to the other side. And then now I have an expression for that H. So I could do B sine H right here. And that's going to be the precisely correct height for my triangle to then plug into the formula. And so this is kind of where the formula that I wrote here is coming from, where A and B are going to be two sides that kind of hug another angle in the middle that is not kind of corresponding with either of the other two sides. Like this side corresponds with that angle, and this side corresponds with the angle across from it. And so we specifically are able to use this formula whenever we have a side angle side scenario happening with the known values of our triangles. And what we can do here is we could start thinking about triangles with common angles. So if we zoom in on this one, we have a triangle here with a side of 2m and n, and we have some angle here that we don't really know yet, and there's some side here that is kind of on the bottom side of the inner triangle there. And I wanted to find another triangle with a common angle, and it's going to be the big one. The big one has the same common angle down here at point B, and then this side is going to be longer. That's going to be 3m, and the vertical side is going to also be quite much longer. It's going to be 4n, and I'll kind of just connect the two sides because they're connected up here. And I want to find the ratio of the area of these triangles. We can use the sine area formula to kind of get some expression of the area. Down here, I would do 1/2 times 2m times n times sine b. That's for the small triangle. And for the large triangle, the big one that we actually know the area of, the area formula here would be 1/2 times 3m times 4n times sine b. And this is just the number 48. We'll keep that in mind for now. We could actually set up a proportion between these two triangles. There's a lot of stuff in common that we could cancel out. So I want to see if I can find some kind of common ratio. And then as a little note, if you want to simplify a ratio, you're allowed to just divide stuff on both sides, kind of like a fraction. And so the ratio 2 to 4 is the same as the ratio 1 to 2. And so I want to cancel out a lot of common factors. These m's can cancel, these n's can cancel, and I don't even know what the values are, but they'll be the same, so they can cancel. And then likewise, sine of b and sine of b are just some number. They're the same number, and I can cancel them on both sides. And then finally, the 1/2 can go away. And so all I'm really left with is the ratio 2 to 12, which I can then simplify to 1 to 6. Or I could actually unsimplify it. I could multiply this side by 4, which would mean to keep the ratio the same, I'd have to multiply this side by 4. And I'm going to get the ratio of 8 to 48. And this is actually the ratio of the areas, right? Because I started with the area formula, and then here's the 48, that is the area of the larger triangle. And so this 8 is going to precisely be the area of this small triangle down here. I don't need to know the lengths. I don't need to know the angles. All I really need to know is how to compare it to the large triangle. So with that process, now I know that area is 8. And let's do that with the other two triangles so that we could kind of figure out what this is and that is, and hopefully we can subtract all of those from 48 to find our middle area. So let's target the other triangle on the left. I'll use the variable p to just kind of represent these unknown lengths at the top. And so I'll have another triangle, the big one again, with a side of 2p and another side of 3m with the same angle. And really all we need to do here is compare these coefficients. Like if I multiply everything and cancel everything, it's basically going to be the same thing as just finding the ratio of this right here. And then the p's and m's cancel, so it's another ratio of 1 to 6, which was the same 2 to 12 that we saw in the last triangle. And so this triangle also has the area of 8. And so there's only one more triangle that we need to study. It's going to be the one in the top right corner with that letter C. There's going to be a P and a 3N. And then the big triangle is going to have the same 2P at the top and a 4N on the side, same angle C in the corner. And again, I really only need to compare 3PN to 8PN. And again, the P's and the N's cancel. And so the ratio here is 3 to 8. So I could multiply both of these by 6. So I can get the the ratio where the 48, the area of the larger triangle, shows up in the ratio. So this triangle here, it does look bigger, and the numbers do show that, yes, it is bigger. So if we take our 48 and subtract out our 18, that's a 30. And then finally, when we subtract out the 2 8s, I'll just do a minus 16 for that. Then we're finally going to get the 14 that matches today's date. So this problem honestly was really hard for me. It took me about 20-30 minutes to really think of a solution. I had to Google some stuff, and I was reminded of this sine angle formula. And finally, that's what kind of unraveled the problem and let me discover a good solution for the problem today. So that's my solution. Hope you enjoyed, and I'll see you tomorrow. All right, bye.